Alright, so applications of derivative. We are going to look at some function, and from that function we're going to be able to tell what's going on with the graph of that function. We've already done this quite a bit. So, for example, if we are given some function that looks like this thing, we'll call that f, we can figure out where all the maximum values are going to be. We can figure out where the minimums are going to be. There's a lot of other stuff like x-intercepts. And so we'll start with the definition. If f prime of a is equal to 0, or f prime of a does not exist but f of a does, then f of a is a critical point, where a is just the critical number when it's by itself. Okay. And secondly, let x be a number in the domain of f. F of c is going to be an absolute max if f of c is greater than or equal to f of x for all x in the domain. An absolute min if f of c is less than or equal to f of x for all x in the domain. So the way that we would find these, we did this in class, is we want to find all solutions to f prime equals 0. Remember, those are critical numbers. We're going to evaluate f at those critical numbers and then the endpoints. The largest value is going to be the max, the smallest value is going to be the min. The absolute max, absolute min. So let's take a look at a different example. We want to find the absolute extrema of 3x to the 4 minus 4x cubed minus 8. That's our function. And we're working on the interval -1 to 2. So just for reference, there's the picture of this thing. There's the graph. And we're going to go ahead and find the critical numbers first. Alright, so f prime is going to be 12x cubed minus 12x squared. If we set that equal to 0, we end up with x equals 0 and x equals 1. So we get two critical numbers here. So again, all we have to do is test these, test the critical numbers, test the endpoints, and we're good. So this is what we get. -8, -9, -1, and 8. So we can see that the absolute maximum is going to be 2, 8. The absolute minimum is going to be 1, -9. Alright, so let's look at this mountain range from the side here. If we wanted to know where the top of each of these little hills on the mountain, where the top would be, we'd have to look at the peaks and the valleys of the mountain range. So we would see that all these different peaks are the highest points in their respective areas. But then we also have the lowest points in their respective areas. Those would be the valleys. The same thing is going to hold for a function. So let me actually just trace that thing. And we're going to make that into a function f. So our extrema are going to occur at the peaks and the valleys. So if we can always imagine our functions to be viewed from the side as mountains, we can just figure out where the extrema are going to be by the peaks and the valleys. So here we have a local max and a local min. We have an absolute max, local min, local max, and then we have two more local min values here. So remember, our derivative is just going to give us the slope all the time, and that's going to tell us about the function itself, not just the derivative. So if we're going uphill left to right, that means that f is increasing. And similarly, if we're going downhill as we go left to right, we're decreasing. And otherwise, if we're not going uphill or downhill, then we're going just straight across. We are constant. And we don't care much about constant right now. Alright, so graphically, we can figure out what's happening here. If we were to ride our bike left to right, from negative infinity all the way up to negative 15, we'd be going downhill. And that means that we would be decreasing. But then we'd be going uphill until we got to negative 11. But then downhill again until we got to negative 7. Now we're going to be going uphill for a while till we get to 8. Downhill forever. We do want to be careful here because we don't want to include the endpoints. Those endpoints are looking like Extrema. And at Extrema, we know that we have a horizontal tangent line. So we do want to be careful there. And let's look at a theorem. So suppose f is continuous on closed AB, differentiable on open AB. If f prime of x is positive at each point in that interval, then f is increasing. And next, if f prime of x is negative at each point in that interval, f is decreasing. So if we want to find the intervals of increasing, decreasing for this function, we need to figure out where the derivative is going to be 0. And then in between those critical numbers that we find, it's going to either be increasing or decreasing, one or the other. So we get 6x squared plus 6x. If we set that to 0, we get x equals 0, x equals 1, negative 1. And so we're going to break up the real number line at 0 and negative 1. And now we're going to test f prime in those intervals, and that's going to tell us about f. So our first test point here, in negative infinity to negative 1, we could choose x equals negative 2. So we get a positive value. If we get a positive value for f prime, that tells us f is increasing. Next, for the next interval, negative 1 to 0, we'll choose x equals negative 1/2, which is negative. If f prime is negative, f is decreasing. Lastly, the easiest test point, we'll choose x equals 1. If we plug that in, we get 12, which is positive. And that means that f prime is positive. F is increasing. And so we can sum this up. F is increasing on negative infinity to negative 1, union 0 to infinity. Decreasing on negative 1 to 0. So look at what's happening between the intervals of increasing, decreasing. This is the example that we did before. We can see that at those peaks and valleys, our tangent lines are horizontal, which means they're critical numbers. But that's actually where our extrema are going to occur. So notice that if f goes from decreasing to increasing, we have a relative minimum. And if we go from increasing to decreasing, we have a relative maximum. This is actually called the first derivative test. Alright, so suppose f is continuous on AB. And there's a c somewhere in there. But c is going to be a critical number. If f prime changes sign from positive to negative at c, c is going to be a local max. Negative to positive is going to be a local min. No change, no extrema. So here is the summed up intervals of increasing, decreasing for us on the last one. At -1, we went from increasing to decreasing, so that's got to be a local max. Zero is going to be a local min. And we use relative and local interchangeably. Also, when we see absolute, you might see global to say absolute extrema.